Recursive formulas are simple, but long, okay? They take a long time to generate. So if, I was going to say, so if we are looking for T12 in a recursive sequence, you need T11, which needs T10, which needs, and if you're in computer science, which I don't know if you've already noticed it's a loop, okay, we're noticing there you need things again and again and again, okay. We thought, I don't know if we did recursion last year, Jake, or not, we must have this. Okay. Enough with that then, okay. T1 has a special name, so T1 is the base case, which are given numbers. Why do you need a given number in a recursive sequence? And this is a really important concept, so if you're still dreaming about snow, this is the time to focus in here. Okay, why do you need a base case? Why do you need to have a given number in a recursive sequence? Yes. Exactly. Right. If I say find the 100th term, which means you need the 99th, when you get to the first term, well, then you're going to need the 0th term, and then the negative first. You know what I mean? Like you need a stopping point somewhere along the line. Okay, right, and that's what we call the base case. In the, we'll talk about the Fibonacci sequence in a little bit, right? But the given numbers for Fibonacci are the 1 and the 1. Right, and then from the 1 and the 1 you get the 2, and then 3, and then so on and so on and so on. Yeah. It could be anywhere along the way. I should say there has to be one for this. Okay, right. And okay, so I'm gonna do example 1. You guys want to what's that there? It's going to say again, write the first 4 terms in the sequence. T1 equals 3. Tn equals 4. Tn minus 1. Okay, now do not freak out. This looks scary. It is not scary. Well, let's print it for you. T1 is equal to 3, and Tn is equal to 4. Tn minus 1. So let's just start writing things out here. Okay. Where do we stop after spider? Be brave. We're looking for T1. What does T1 equal?
3.
Good. It's given to us. That's our given case. Lovely. We can say given. Okay, now I'm going to open this up to anybody rather than put anyone on the spot here. Okay. T2 is a little bit trickier here now. How can we get T2? Let's think here. What's the end value for T2? What's the end value? N's 2. So what's T2 going to equal? Go ahead.
It's going to be T1.
Yeah, good. So if n is 2, n minus 1 is going to be 1. Very good. So this is going to be 4. That's T1. Now before I move on, I got to make sure this is rock solid. Please ask if there's a question. Do not be shy. As a joke here, while you guys are thinking of this, everyone I hope asks for graph paper and rulers and calculators. Your sister probably gave you hers. She doesn't need it, right? Is that what it is? Right. Are we okay on that? Because n is going to be 2 here. So for 2t, n minus 1 means 1 less than that. So 4. Okay, so to go from there, then that's 4 times 3, which is 12.
So what would that be again?
Okay, because n is just a subscript here, right? So n is going to be 2. Yeah, and then this is going to be, n is still 2 here, so 2 minus 1, which is 1.
And I'm just sort of confused because instead of like a big like what is was it you described that I just gotta get some of the program, but it's.
Well, they are, but the thing is, we're only at the first half of the lesson. Second half is going to a sequence and working and getting making this the sequence, right? That's what it is. Okay, Caitlin, you're up. Can you do T3 for me, please? Okay. Okay, good. So 4 times T2, right? Right, because the subscript, and it's going to be 3, it's going to be 2. T2 is be 12, so 4 times 12, which has to be 48. That's good. Joel, finish off, please. T4 is going to be?
T4 is 43, which is 4 to 48.
Which is, what is that, 192, I think? That's when I look at my sheet. Yeah, look at that, it is 192. Okay. So the sequence is 312, 48, 192. That is an exponential sequence, is what that is. And we'll get to talk about that a little bit more later. Okay, I'm going to hit pause here in a sec. I want you guys to try the next one for me. Since people are saying this is way too easy, let's get you harder on that. Make sure this is good here. Better simple 4 is going to be write the first 4 terms in the sequence. T1 is 3. Sorry, T1 is -2. T2 is 3. And Tn equals 2. Tn minus 2. I'll remember here. Ah. Oh, I'm having a rough. Okay, let's try and refocus. Tn equals 2 Tn minus 2 plus 3 Tn minus 1 plus 1. Okay, as that's being written down, what is the scary part of this before I let you guys try this? There are lots of T's. Okay, that's okay. You guys are coffee drinkers, so you like tea. Okay, I'm sorry. I don't know lots of. What's the scary part of this? What's the new part of this question? Yeah, what is that 2 Tn minus 2? What does Tn minus 2 mean if you had to guess? Sorry? N minus 2, right? So if n minus 1 means go before, n minus 2 is going to mean 2 before, 4 before. Okay. So that's why in this case I have to give you 2 base cases. Like if I start at T2 and I say go back to this one, 0, which can't happen. Okay. So I'm going to hit pause on my recorder. I want you guys to try this out, and then we'll find out how to make these. Hopefully. Where are you? Well, I'll guide you guys through this. I'll start with this here first. Lucy, T1.
All right, well, you've got 2T, and then you've got the, well, yeah, T1's -2, and you've got T2, which is 3.
Okay, stop right there. Stop right there. That's good. Okay, you have to write these down. These are still part of your equation.
I wrote those down off this one. I was just saying what that.
Oh, that's okay. Okay, but please make sure you put those down. Those have to be your starting points. That's how your sequence begins. Without those 2, you can go nowhere. So please write those down. Okay? All right. Lucy, continue. What's T3 going to be? Go ahead.
All right, so far what I've got T3 is 2T, and then because n equals 3, it's 3 minus 2.
Yeah.
Plus 3T, 3 minus 1, and then plus 1, which is 2T, 1, which
Yeah.
is
Okay, so on.
negative
Yeah,
2
good.
times 2.
Yeah, we'll just write this. That's good. Okay, so very good. Okay. So again, what you said correctly was n was 3, so n minus 2 is just 1. Right, so change to 2T1. N is going to be 3 on for the next one, so 3 minus 1 is 2. Wonderful. Okay, so who's up next? Who are we up to? I think, Maddie, we're back to you, I think. All right, Maddie, sum some numbers for me, please.
So,
Good. Okay, so then I'll put a -4 plus 9 plus 1, which is 6. Now, here's the problem. You're saying, Mr. Sadler, I don't see this as more difficult. Okay. The problem, the frustrating part of the first formulas are, if I were to say to you, Arden, which I'm not going to say, please find T10 for me. Okay, that's where there's no easy way to do it. And I wish I could say there's magic. There's no magic to this. There cannot be any magic to it. Yes. That's where computers are used to look, because they can do this sort of stuff super, super fast. Okay, but that's, it takes a long time. What I will say to you, Arden, instead of finding T10, I will say you find T4 for me. So if you can do that for me, please. T4. Yeah.
Plus 3t.
2. Yeah, there you go.
Plus 3t3.
Yeah, I'm going to write it like this. If you need to show another step, that's okay, but that's going to write it like that. Wonderful. All right, Sabrina, can you sub some numbers in for me, please? If you'd be so kind. Yeah. Good. All right, and we're just picking the numbers in. Okay, so this is 6 plus 18 plus 1, which is 25. Sequence is -2, 3, 6, 25. Now this is where math gets hard, okay? Because what we're going to do in our next section, I'm just going to try to finish it all today, is I'm going to give you that sequence. I'm going to say make an equation, right? And that's the difficult part, right? Like, what we've done with this one, Lucy's right. This isn't hard to be done. Here's the equation, sub into the numbers, pull it out. The difficult part is going backwards. That's what I'm going to do right now. I'm going to hit pause and let you guys catch your breath, and then we will continue.